My name is Dmitrijs. I'm happy to continue the Skylab sub-session in this conference. Thank you, thank you. And I will be talking about the exploration of olfactory interaction spaces. And when I talk about smell, which I do a lot, people always say, well, don't just talk about smell, but give us something to smell. So actually I brought a small bottle with me, which one of the student volunteers will pass around, so that you can sniff some relaxing smell and chill while I'm talking. All right, so the natural question that arises is why to use smell? Well, smell is a very strong medium. It has very powerful link to our emotions and memories. And of course, it's very complicated to apply because of a number of issues, but yeah, that's what I'm here for, to tell you how to work with smell in HCI. Yeah, and actually when I started working with olfactory interaction, I was very much lost because there's not only very little research about this topic, but also everyone tends to do it in their own way and for their very specific prototypes. And no one seems to be tackling the problem as such. So how to tackle the problem of olfactory interaction. And that has what has motivated me to work on this research activity. So I looked up what is available on the topic of olfactory interaction spaces, and I realized that the most common problems are the contamination, because if we use the building's centralized ventilation system, then basically the whole building would stink at some point. Also the materials tend to absorb scents, which is not what we want to have. And if we want to apply smell in HCI, we of course need a device which would deliver this scent to the user. While going through different prototypes, I have extracted some characteristics that a scent delivery device should have. And first of all, one of the most important ones is the delivery distance. So the smell has to travel across a certain distance so that we have freedom of hand movements in front of us, and we can actually do something meaningful with the prototype. And for example, here on the left, we can see that the distance that is used is not feasible for many applications, whereas on the example on the right, there is plenty of space, not only for hand, but the whole body movements. Another thing that is important is to keep the scent channels isolated from each other in order to exclude the cross-contamination of the scents. On the left, you can see the not the aroma shooter, but the Dale Air Vortex device. It does have 4 separate scent channels, but they are not completely isolated from each other. So the scent molecules can go outside the tubes even if the device is off, and then mix with each other. So it's very hard to get a clean scent out. But in the example of Nakamoto, he was using plastic tubes for every scent channel, which basically excluded cross-contamination issues. Then another important aspect is the control of the blowing time and scent intensity. And there are devices with APIs which are offering that. For example, the aroma shooter, which is on the left. So the device comes with an API which enables this functionality, and there are also more sophisticated devices used in olfactory studies. And finally, in olfactory HCI, we don't want the user just to receive one smell all the time, because it's very hard to do interaction with one smell. So there is a need to have multiple scents within one session and also to exchange them between the sessions. And on the right, we can see a device which contains 6 scent cartridges, whereas on the left, there is a device with only 1 scent cartridge. So now I went through a number of different recommendations on what a scent delivery device and an olfactory interaction space should have. And in my proposal, I have summarized them all by writing down the OSpace Framework, which basically is a set of recommendations on how to tackle the problem of olfactory interaction. And based on this framework, we have built our own scent delivery device. We have used an air tank, a tank of compressed air, which would split the airflow in 6 channels. And using electric valves controlled by an Arduino board, we could precisely trigger the moment when the clean air flows into one of the 6 scent containers, and then this smell is traveling to the user's nose. And this is how the prototype looked in real life. So on the left, we can see the air tank that I have mentioned and the actual device with 6 scent containers, which are glass jars, and the electric valves on the top. And on the right, we can see the output nozzle, which is basically collecting the 6 scent tubes together for the output. And this is how we developed our olfactory interaction room. So it's actually a room in the room with its own ventilation system, which I have said is an issue when working with smells. There are 2 air extractors located outside and also a clean air blower. The device itself is also located outside the room, and only the scent delivery tubes and the extraction pipe are going inside the room. And for the experiment, we have set up a chair and a table inside, and in order to keep the participants' head constant across the trials and across the experiments, we have used a chin rest. And you can see the nozzle was located in front of the user's nose. This is how the room looked from outside. We have used black, odorless water-repellent fabric to cover the room. And the room itself is a former clean room, which is made out of plastic and metal, so again, materials that do not absorb scents. And we conducted a user study with this setup to see how it works. We have done a mixed model study with 21 participants. We have studied the different scents and different dilution levels as a within participants condition, and the air pressure was explored between participants because our current setup did not enable air pressure changes within the session. This is how the setup looked inside the room with the participant inside. So basically, you can see the blue nozzle pointing towards the participant's nose, and there was a screen on the left where the graphical user interface was displayed, and we basically asked the user to press the start button when they started perceiving a scent, and they had to click stop when they didn't perceive the scent anymore, and we were recording these times. So we realized, we found out that basically any of the scents that we have explored could be detected within 10 seconds, and also it took just as much as, or as little as 9 seconds for the scent to disappear. which is, of course, not fast enough for real-time applications, but there is still a range of different application possibilities where this time is feasible. For example, we can think of the olfactory feedback notifications or multisensory cinema, where the transitions between scenes are smooth enough to let the scent disappear and release another one. Our results suggest that there might that the detection and the lingering time of the scent might not depend on the scent type, but of course we need to study it with a bigger sample size. And we can see that lingering is not always a problem. So in our case, the smell did go away in 9 seconds, whereas in many other pieces of research I have seen in the related work, lingering was addressed as a big issue. So it's there, you cannot fight it, and it's a limitation. Yeah, in this conference we always speak about the applications, so we did not just study this setup. In one of our next studies we actually applied this knowledge to build a olfaction-enhanced driving simulator. I will not talk about it much today because it's a different paper, but just to give you an idea of how to use this in practice. So to conclude, well, we can say that smell, as we can see, can be useful for HCI. We cannot only talk about limitations of scent cross-contamination and lingering artifacts. If we take a good control of the parameters, if we can keep the scent channels isolated from each other and we release just a small amount of the odorant, then we can achieve a meaningful interaction, and the user would not be confused by some previous scent which is still in the room at the moment the next scent is coming in. So this is possible. What I actually am really happy about in relation to this research is that we are doing the initial steps towards a common design framework, which is a problem in olfactory HCI so far. And I hope that if you decide to work with olfactory interaction, you take this as a starting point and you extend this and contribute to this framework as well, so that someday we have an olfactory interaction standard, so that no other researcher is lost as me 2 years ago and can actually refer to something which is common for everyone. And with this positive take-home message, I close, and I thank you for your attention.
Thanks a lot, Dmitrijs. We do have time for questions. I think we have one over there in the back.
Hi, thanks. So I wanted to ask, similar to how we sometimes get immune to vibrations or haptic feedback, that I guess happens more with smell or taste. Do you have any thoughts on that?
Yeah, a very good question. So in olfactory studies, we have the problem of habituation, also referred to as adaptation. So if we are exposed to a smell for a long time, then on some point we don't notice it anymore, and our olfactory function is numb, so to say. It is an issue indeed, but there has been research done on that, proving that if we release the scent in small chunks, in the periods of, say, 30 seconds, then this is not the case. There is enough time for the olfactory function to refresh, and the habituation is not happening. And in fact, in my study, I also made sure that the gaps between the stimuli are long enough for participants to not develop habituation.
Thank you. Very interesting work. I have a couple questions. One is, I guess, the potential health impact of olfactory input. I know in Canada there's a lot of move towards scent-free buildings and things given environmental allergies. So what's the general consensus in the field about that?
Yeah, very good question. Thank you. In fact, I had to go through at least like 3 iterations of ethics approval until this got through. Yes, the sense of smell is a chemical sense, so there is a risk of allergies indeed. So far we are just taking scents which are approved, which are known not to cause allergies, and we also ask every participant if they have strong reactions to smells, any allergies, and only if this is not the case, then we proceed. But yeah, I also hope that chemistry will progress designing smells which are good for everyone.
Are we out of time, Diego? I have a different question, but
we have time for one, but maybe the next speaker.
Anyone else have a question? Okay. So 2 years ago, I had a major house fire, and through that experience, I learned that people have very different sensitivities to smell. So we're very good at smelling smoke now, and that's not the case for lots of people. And so how do you deal with that? How do you even measure someone's just, do they have a good nose or not?
That's a very good question. It is indeed very hard to generalize when studying olfactory function. Well, we have self-report question where we ask participants to rate their sensitivity to olfactory stimuli, and mostly if people say that they are good in it, then their results do not deviate from the mean much. So this is how we deal with it so far, but it's indeed a problem. Yes, there is much more variability than in visual studies, for sure. Yeah.